Before forests, before dinosaurs, before a single heartbeat echoed across land, there was water. An endless, restless ocean beneath a sky thick with volcanic haze. Lightning tore through methane clouds. Asteroids still scarred the young planet. The crust cracked and shifted. Steam rose from fissures where magma met sea. Earth was not peaceful. It was unstable, violent, alien. And yet, within this chaos, something extraordinary was beginning. In waters once thought sterile and lifeless, chemistry was becoming biology. This is the story of the first life. More than 4 billion years ago, Earth finally cooled enough for rain to fall. Not for days or years, but for centuries. The planet flooded. Vast oceans gathered in volcanic basins. Minerals dissolved into the water. Iron, sulfur, carbon, the ingredients of complexity swirled together in a chemical dance. Along the ocean floor, hydrothermal vents hissed and pulsed. Superheated water, rich with dissolved metals, surged into the dark sea. Here, in crushing pressure and absolute darkness, nature experimented. Not with animals, not with plants, but with molecules. Within microscopic pockets of warmth, simple compounds assembled into more complex chains. Membranes formed. Boundaries emerged between inside and outside. For the first time, chemistry began organizing itself. Life did not appear in a flash of light. It emerged quietly. Somewhere in the depths, perhaps near a hydrothermal vent, perhaps within sunlit tidal pools, a molecule gained the ability to copy itself. Replication, the most powerful innovation in the history of the universe. Once something could make another version of itself, evolution began. Imperfections followed, errors crept in, variations formed. Some structures were unstable and dissolved back into the sea. Others endured. Natural selection had begun, long before eyes, long before teeth, long before survival meant running or hunting. Survival meant persistence. Eventually, membranes strengthened. Primitive cells, ancestors of all living things, enclosed fragile chemistry within protective walls. Inside, reactions could occur more efficiently. Energy could be captured. Information could be stored. These early microbes would resemble what scientists now call prokaryotes, simple, single-celled organisms without nuclei. Not impressive by modern standards, but revolutionary for their time. They fed on chemicals dissolved in the ocean. Some consumed hydrogen, others relied on sulfur. Life did not yet depend on sunlight. The world above remained hostile, bathed in ultraviolet radiation beneath a sky without oxygen. But beneath the waves, life multiplied, slowly, relentlessly. The early Earth was dim beneath thick atmospheric haze. Oxygen was absent. The seas were rich with dissolved iron, giving them a greenish tint. And still, life endured. Microbes clung to rocks, formed thin mats along volcanic shorelines, clustered around vents where energy flowed from the planet's interior. They divided, they adapted, they competed. Some evolved the ability to harness light, primitive photosynthesis. They captured photons and used them to power chemical reactions. This was no small shift. It was the beginning of planetary transformation. Tiny cyanobacteria-like organisms began releasing a waste product into the ocean: oxygen. At first, it bonded with dissolved iron, rusting the seas. Layer upon layer of iron oxide settled onto the ocean floor, creating vast banded formations we still mine today. The planet was changing, molecule by molecule. For hundreds of millions of years, life remained microscopic. No movement visible to the naked eye, no sound, no predators stalking prey, just cells dividing in endless cycles beneath the waves. And yet, this was one of the most important revolutions in Earth's history, because oxygen, once a toxic byproduct, began accumulating in the atmosphere. It would eventually trigger a mass extinction of early anaerobic life. It would reshape the chemistry of the oceans. It would allow more complex cells to evolve. It would make breath possible. The air you inhale today carries the legacy of those first microbes. Every forest, every animal, every human owes its existence to organisms too small to see. When we imagine the beginning of life, we picture dramatic moments, but the truth is quieter. Life began as persistence, as fragile membranes trembling in mineral-rich water, as chemical reactions refusing to collapse, as microscopic pioneers enduring a hostile world. There were no witnesses, no sunrise celebrations, only survival at its most primitive. And yet, from that silent ocean floor came the blueprint of all biology, the code that would one day build coral reefs, redwoods, whales, and cities. The story of humanity does not begin with fire. It begins in water, in darkness, with a cell too small to see, but powerful enough to change a planet. And in that ancient ocean, beneath a violent sky, Earth took its first breath.